Okay, today's lesson is on parallel lines, and you can see from the top of the page, we're going to test 1, section 4, number 3. We've got two sets of parallel lines here. I drew out the picture for you, and I'll read. In the figure above, lines L and M are parallel, and lines S and T are parallel. So they don't tell us that on the picture, so we're going to indicate that with our little arrows. And for here, we'll do 2 arrows to distinguish them. Okay, it says if the measure of 1 is 35. And we'll just make that. We're going to label everything because we are so awesome like that. And then it says, what is the measure of angle 2? Okay, so parallel lines. The idea first is to label everything you possibly can. So we talked about vertical angles being equal. So if 1 is 35, then this angle opposite is 35. Now there's the issue of the straight line. Straight lines, like so, are 180. So if part of that 180 is 35, we take that away and we get 145. So this angle is 145, and likewise, this vertical angle is 145. Okay, so that's our first step. Now, somehow we have to get from here all the way down to 2. So I'm going to show you what I call the dot and circle rule. You make a dot at the juncture of one of the parallel lines and the transverse line running through it, and then you circle all of the angles encompassed therein. If you take a line, now here we have a couple of sets of lines, so that's okay. I'm just going to, for example, go down this transverse line until I hit the next parallel line. I put a dot there, I put a circle there, and this circle is going to be exactly equal to this circle, right? So I just fill in here the same exact numbers. Now I can continue that because these two, S and T, are also parallel. So line M is like the transverse of those two. So I can just keep going to the left and dot and circle these. And we can see that angle 2 is going to also equal 145 degrees because it's in this same quadrant here. Okay, so that's the dot and circle rule. I like that rule. It's good, definitely good to know. Okay, our next problem is on test 2, section 3, number 6. And I've drawn out the picture. The question reads, in the XY plane above, line L, which I did not label, is parallel to line K. So we make our little parallel arrows. And it says, what is the value of P? Now, the main point here is that parallel lines, or that's the notation for parallel lines have equal slopes. You must know this in order to do this question. You must also know the slope formula, which we will use here. Now, you do not have to use the formula. You could count up and over, right? Up and over to find the slope. But I don't trust my picture, and I actually want you to get some practice using the formula because sometimes you need it. Okay, so we're going to find the slope of line L because we have 2 coordinates. So we're going to subtract the y's. We're going to say 2 minus 0. And you have to do this in order. So if you start with this coordinate, you have to continue with that coordinate for the x's. So it's going to be 0 minus negative 5. And that turns out to be 2 negatives is a positive. So it turns out to be 2/5. So line L has the slope of 2/5. And then, I'm just going to put that there. And this is how you should do it on your page, like on your test. You should label everything so it's very clear. So you're not wondering, what is this 2/5 again? What did I just solve for? Okay, now we know that line L has a slope of 2/5. So that means line K has a slope of 2/5. So we can just take this, right, and plug in 2/5 for it. And then plug in the rest of our numbers. So we're going to take the y, so it's going to be 0 minus -4 over p minus 0. These, again, turn positive. 2 negatives equal positive, and it's 4 over p. So we've got 2/5 equals 4 over p, and then we can cross multiply. And we get 2p equals 20. Divide out that 2, and we get p equals 10. And there you have it. And we're going to move on to another concept. This one, I haven't seen that often, but I've seen it sometimes, and I just want to put it out to you, just in case. I want you to have all the tools that you possibly can. We've got 3 parallel lines. This looks like maybe let me just make it look more like a regular parallel line. Okay, and let's say we have a slanted line. We're talking about here, this line here, and this segment of that purple line is x. And let's say this one is 3x and this one is 5x. Now, if we say that from here all the way down to here, right? That height, let's say we say that is 18. Here's the rule. This is called the proportional segment theorem. And I don't care if you don't remember the name, okay? It's the concept. It's that typically you don't think of a slanted line as being able to, as being the same as a vertical line. But in this case, it's true because these lines are parallel. Okay, so when you see parallel lines, you can add up the entirety of, let's just get rid of that. Okay, it just goes from here to here, right, like that. You can add up the x and the 3x and the 5x. If we add those, we get 9x. That is going to be equal to the 18. And then we can just divide out the 9, and we get x is 2. So we can say that the x is 2, the 3x is 6, and the 5x is 10. So if they were asking us to solve for x, we get it. If they ask us to solve for this segment, we get it. And if they ask us to solve for the biggest segment, we get that. Okay, so proportional segment theorem, where the slanted line actually equals the length of the vertical line.